Algebra 2, here's your Chapter 6 Self-Assessment Review. This will help you for your test this week. Make sure I'm all plugged in. I am. Okay, here we go. So, starting at the beginning here, simplify the expression without the use of the calculator. Write answers with positive exponents only. Okay, so fourth root of 81. Well, 81 is 3 times 3 times 3 times 3. So, there's that. Okay, so when I take the fourth root of 81, it's just going to be 3 itself. What multiplied by itself 4 times is 81, 3. 4 goes into 4 one time, and 4 goes into 7 one time. And so what is stuck underneath the fourth root, if you will, that would be the remainder when 4 divides into 7, y cubed. So this answer is 3xy fourth root of y cubed. Okay, next one, the cubed root of 8. Well, negative 8 that is. Negative 2 times negative 2 times negative 2. Okay, so cubed root of negative 2 cubed is just negative 2. 3 divides into 3 one time. 3 divides into 8 twice with 2 left over. Okay, so that's just 3 into 8 goes twice. So that's 6, and then that's a remainder of 2. And then, wow, 31. Okay, so 3 goes into 31 10 times. That's 30, and that would be 1 remainder. So this final is negative 2xy squared z to the 10th cubed root of y squared and z. Okay, and then the last one, this negative here, I'm just going to go ahead and do like we did in class and just do power to power. So 4 to the negative 2, x to the negative 2, and then y to the negative. Negative is positive. So just being aware of that negative 2, I like to instead of reciprocating all this, I like to just do the power to power first. But whichever path you take works, but this is the one I'm going to use. Okay, so 16 to the negative 2, x to the negative 2, and then y to the negative 4. All right, so then I'm going to make everything comfortable, if you will. All right, so 16 squared is going to go up. 4 squared is going to go down. This x squared is going to go down, and this x squared is going to go up. But really, anything over itself just cancels. So you could just sort of cancel those right there. Y squared is still in the numerator, and then y to the 4th. Okay? So this then is going to be 256. I'm just going to take it on to the answer place. 16 squared is 256. I have 6. 1, 2, 3, 4, 5, 6 y's right there, 2 plus 4, and then that's all over 16. And actually we can do, we could have actually canceled this in the beginning, this 4 into 16 to make our life a little bit easier, but we can also catch that canceling right here. So 16 goes into 256 16 times. So your final is 16 y to the 6th. Okay, so now that I'm on the other end of that problem, it probably would have been easier to simplify first. So let's just model that. I just went for it straight away and didn't even stop and see if I could make my life easier. So let's make our life easier. Just so another method here. If you went ahead and canceled, 4 goes into 16 4 times. And the x's just cancel right here, so you don't even have to deal with them. And then you could go ahead, if you wanted to send that y down, you could go ahead and send that y to the first down here, and you'd get everything from the top is now gone, y cubed. And then raising that to the negative 2 would just flip it to 4y cubed squared, which is your 16y to the 6th. So that's just maybe an easier way. 16y to the 6th. Same thing. I mean, as long as you follow the rules, you'll get to the right place, either order of simplification. Okay, simplify the following. So cubed root with cubed root here. So this means I just need to rationalize. There's really nothing, 7 and 3, x and y squared. Nothing I can really do, so I'm going to rationalize the denominator. So I'm going to multiply by a root 3 over a root 3, and my goal is to make this be a cubed root and this be a cubed root. So I need 3 to be something that I can take the cube root of, and that's going to be 3 times 3 times 3, which is 27. So basically I need 3 squared here, 1, 2, 3 3s, and that's just 9. Okay, so I want to do that on top and bottom, and then I need 3 y's here. I already have 2, so this is like so. So in the numerator, that's just 63xy. That's all I can really do there. And this is 27y cubed, which of course then, just heading over to the answer, 3 root, or cubed root of root 63xy over, and that's just 3y. Okay, so I'm going to get this 3 nestled into that little root right there. Okay, and that's it. All right, this next one, this little box just didn't translate. That's just multiplication, cubed root and cubed root. So I've got the cubed root of 64 and a total of 8, 9, 10, 11, 12 here. So the cubed root of 64 is 4 times 4 times 4, and 3 goes into 12 4 times. This is 4x to the 4th right here. All of my answers here. Make this a little bit neater. That one's box here and here. All right, next one, let's simplify first. It's all under the radical, so let's just do this. 2 goes into 50 25 times. More x's on top by 7, more y's on top by 4, and more z's on top by 1. Okay, so in simplifying, it makes my life easier. I don't have to rationalize the denominator. And the square root of 25 is 5. 2 here goes into 7 3 times with 1 left over. 2 goes into 7 3 times with 1 left over, 1x that is. 2 goes into 4 twice with 1 left over, and 2 does not divide into the z. So this final is 5x cubed y squared, square root of x, let's see, that's just, there's no y under there, sorry. I'm still focusing on that 5 up there, okay. Okay, and z. So that should be the correct answer for that one. All right, number 7, rationalize this denominator. So I'm going to multiply by the conjugate. Okay, so up top that'll be 4 times root 7 plus 1. That's going to be 4 times both of those. All right, and then on the bottom, since I'm using the conjugate, I can just F and L it. Root 7 times root 7 is root 49, which is just 7. And then negative 1 times positive 1 is minus 1. Okay, so this is 4 root 7 plus 4, and that's just 7 minus 1, which is 6. And each one of those can be reduced by 2. So this will be 2, 2, and 3. So 2 root 7 plus 2 over 3. Okay, 2 root 7 plus 2 all over 3. Alrighty, number 8, root 98 plus root 2. At this point, it doesn't seem like there's anything I can do, but I want to examine what 98 looks like. And it's, when simplified, and it's root 49 times 2 plus root 2, so that is 7 root 2 plus 1 root 2. That is 8 root 2. And I know I'm doing these sort of fast, but that's because you can pause and rewind. Okay, FOIL, F, negative 8. O, plus 6 root 3. I, I'm going to put that underneath because I'm going to combine them and that saves me some room. Negative 4 root 3, and last, plus 3 root 9. Okay, so negative 8 plus 2 root 3 plus 3 times 3 root 9 is just 3, that's 9. So 1 plus 2 root 3. All right, so far so good here. Just looking over everything. All right, next one, let's go power to power. Okay, so this is 1 over 3 to the 6, so that's power to power. Just leaving those bases alone and working up in the exponential position. Okay, so that's 3, a third of 6 is 2, and that's 2 to the 5th. Okay, so 9 times 32 here. Okay, so 32 times 9, 18, 288. Okay, moving right along. 27, negative 27 to the 2/3, so that's just the cubed root. That's the root, and that's the power. So the cubed root of negative 27, and all of that squared. So that's just negative 3 squared 9. Okay, and then this is just the cubed root of 125 to the first power, so you don't really even need that. And so what times what times what is 125? It's 5. Okay, back page. Perform the indicated operation and state the domain. Let f of x equal x minus 1 and g of x equal 2x. So this just says add f and g and evaluate at 3. So I'm just going to add f and g. Okay, super easy, okay. X minus 1 plus 2x is just 3x minus 1, and then just plug in 3. That's just your plug-in. So that's just 3 times 3 minus 1, which is 8. This says multiply f and g, and there's nothing to plug in. So this one I get a number because I'm plugging in a number. This one it's just going to be multiplication. So x minus 1, and then you just have a answer that is an equation. So I'm going to distribute. So this is 2x squared minus 2x. Okay, so notice this is multiplication and this is composition. So this I'm going to plug f into g at x. So I'm going to plug f into g at x. 2x minus 2. Okay, next piece, domain work. Okay, so domain just means, you know, what is x allowed to be, or what can't x not be. And so the two things you have to worry about are a root or a fraction. Anything else, you just say all real numbers. There's no, you know, quote unquote bad guy. So here 2x plus 8, okay, has to be greater than or equal to 0. 2x plus 8 under the radical has to be positive. So how do I write positive? Greater than or equal to 0 means positive or 0. Okay, so this needs to be positive under here or 0, so I'll write it like this. And then you just solve that little equation, that little inequality. Okay, and so the domain is, you can just say x greater than or equal to 4. You know, the most proper would be this. Here, same thing. I need this to be positive or 0. Okay, so that's just x needs to be greater than or equal to negative 3. And the proper way is like so. And then the last but not least, denominator can't equal 0. Okay, it can't equal 0. So 2x can't equal 3, x can't equal 3/2. So any other number in the world is great. So x is all reals, but x can't be 3 over 2. So if you put 3 over 2 into this equation, you know, you're going to get 0 down there, and it's not going to work. Okay, find the inverse, number 19. Finding the inverse of a function. So remember that we just go through our steps. Y equals 2x minus 4. That's to replace the f of x with y. Switch the x and y. That's technically your inverse, but we want to solve for y. So we get x plus 4 equals 2y, which is x plus 4 over 2 equals y, which is 1/2 x plus 2 equals y. Okay? And then you replace it with this F inverse symbol. So it's 1/2 x plus 2 is the inverse. Okay? This next one, so in order for, this is a parabola, and so in order for this to have inverse, that's a function. So right here it would fail the horizontal line test right there. So this just says, hey, let's just look at half of it. Okay, let's just look at half of that parabola. Keep x positive and then find the inverse. That's a little technical, but that's what this is all about. So it's just basically here. Okay, we're going to find the inverse of that piece of it, which passes the VLT and the HLT. So y equals x squared, okay? Interchange. There you go. And then take the square root of both sides. So when I take the square root of x, you would get plus or minus with the square root theorem when I take the square root of both sides. But since this told us to keep it positive, we just say the square root of x and not the plus or minus. All right, and so there's that. Okay, last ones here. Solve the following equation. Show your work when you check for extraneous solutions. All right, I can do that. So I'm going to cube both sides. Which is 2x equals 4 cubed, 64. Divide by 2, divide by 2. X equals 32. And remember, when we do this, we don't really have to check because we cubed. So that's just 32 there. Okay? Here I'm going to square both sides. And that releases. Now this one I'll have to check since I squared both sides. This I'll have to check. Okay? So 3x minus x equals 6. 2x equals 6. Divide by 2. X is 3. So I'm going to check that one. Is the square root of 9 equal to the square root of 9? Yes. So this one works. And then last but not least, isolate. So plus 7 plus 7. That is going to be 16. And it's sort of really up to you. I would just raise both sides to the 3/2. Or you could write this as the cubed root of x minus 3 squared, right? But, and then you could cube both sides and then take the square root of both sides. But this is a little clumsy. When you have it with a numerator that's not 1, I would just use the reciprocal here. Okay? It's just easier and less mess. Okay, so this is x minus 3. Okay, so I am cubing and square rooting. Cubing and square rooting. So when I square root, I have to bring in plus or minus. Okay, so that just negates, and you get just release that x minus 3. So I'm going to square root 16 and cube it. So when I square root 16, I've got to analyze plus or minus 4. So you get x minus 3 is equal to 4 cubed, and x minus 3 is equal to negative 4 cubed. So x minus 3 is equal to 64 plus 3 plus 3. X is 67. You don't have to check these, but you have to. You either need to check them, or you've got to use the plus or minus. Unless it's just a straight cube, then you don't have to really do any of that extra. So this is x minus 3 equals negative 64, plus 3 plus 3, negative 61. All right, so I hope you found that helpful. You have this video, you have your LTQs all solved out on video 2, so you can start this semester off with a really awesome Chapter 6 test score. All right, guys, see you in class. Bye.